this class does a great job of telling you all the really wonderful things about AI. And I hope that that really makes you interested in pursuing it further. And today, I just want to share with you 10 things that I thought would be helpful along my AI journey. So before we get started, a quick disclaimer. So the views that I express in this presentation are solely based off of my personal experiences, my own interpretations of the industry, or anecdotal inferences. They might not apply to everybody and should be thought of as educated opinions more so than hard facts. All right, so with that out of the way, to understand my views and opinions, it's helpful to have a little bit of experience, a little bit of information on my experience. So in high school, I had almost no coding experience. And then in college, I started with the introductory CS class and ended up getting a BS and MS in computer science, where both degrees were on the AI track. During college, I did 3 AI internships at Falconry, which was a small AI startup focusing on industrial uses, Virtue Financial, which is a hedge fund based in New York, where I did financial algorithms for some of their trading platforms. And then finally, I did an AI internship at Google, where I worked on the Maps team and created an algorithm to generate better search results in Google Maps. And now out of college, I work at Google, where I do a non-AI role. I work on the Google Docs team for mobile. All right, so the first insight about AI. AI is hard. And you guys probably all know this from being in this class for the past 2 weeks. The AI is very challenging. There are many different types of AI. It's difficult to conceptualize what's happening on a detailed level. Coding has a steep learning curve in general, but with AI even more so. We have all these complicated libraries and documentation to read through. The math is really challenging. So all these factors combined together makes AI a really difficult endeavor. For me personally, it took about 6 or 7 classes in college to finally feel like I really had a good grasp on AI. But the good thing about classes for AI in college is that they tend to be repetitive. And the information, if you miss it in one class, you'll likely revisit it in another in some shape or form. So my tip for this is to just don't get discouraged. AI is hard and it's hard for everybody, but keep exploring and eventually it'll click. The second insight about AI is that AI is a lot of math, especially in school. So this on the screen here is an example of some partial differential equations that are necessary for backpropagation calculations. And that's okay if that doesn't make sense right now. But you will spend a lot of time in school and on PSETs doing math, and some PSETs will even be mostly math. But the math is actually really important to understand how AI works. And so schools do this very intentionally so that you have a really strong foundation about AI, and that will set you up for success in the future. And what I will say is that schools will focus on the mathematical aspects of AI more so than implementing AI libraries, because they trust that with this solid knowledge, you'll be able to implement them on your own later. So yes, so my recommended tip for navigating this math is to take multivariable calculus before any AI classes and to take it seriously. And also to go to office hours to ask for help with the math. It's going to be very important. And the math is such a very strong foundation. So personally, the math was a struggle for me the whole time because I didn't do well in my multivariable calculus class and I never got those fundamental skills. And so I felt behind a lot of the times in AI classes subsequently because I didn't have that foundation. So I would really recommend getting a very solid mathematical foundation before embarking on AI. Okay, so on the converse, AI is very little math in industry. So the industry has almost no math because it's mostly coding, and instead they make use of these pre-implemented libraries, some of which you may have heard of, like TensorFlow, PyTorch, and Keras. And these libraries will essentially build out a lot of the implementation for the AI for you, but you have to then piece it together and understand how they all work. And this can be tricky, and they can be tricky to debug because they're very complex. So my recommended tip for this is to take opportunities in school to build models from scratch. So when you have opportunities to do projects, as most AI classes do at the end, instead of just cloning a GitHub repository and copying code and then making a few modifications, try building some models from scratch and really getting your hands on how these models are actually set up and how they work. And that will really help you out with learning these tools for industry. The fourth insight is that AI is not magic. So I think that people, especially who are not familiar with AI, have this conception of AI being this magical black box that you can just throw data at and then get back magical results. But the reality is it's very possible to understand how AI works on a detailed level. And AI is also relatively limited in its capabilities. Each algorithm, for the most part, is limited by the data that we provide it. And it also generally only performs one specific task. And these tasks are pretty nuanced. Now, we have developed AI to cover a wide range of capabilities, and overall that's quite impressive, but any algorithm individually certainly isn't magical by any sense of the word. I will say that general intelligence is the next step in the field, which is kind of providing a more comprehensive use of AI algorithms, and that's very cool. But I think that we are still a little ways away from that. So my recommended tip for this is, especially when getting your own concept of the capabilities of AI and explaining it to other people who might not be as tech savvy, be knowledgeable about the cutting edge of AI, read research papers, know where the forefront is in the industry. And that'll help you get a good perspective on things, of what AI is capable of and what it's not. Okay, the fifth insight is that AI is not really computer science or SWE. So I consider AI to be at the intersection of data science and software engineering. It definitely requires a lot of coding, but there's also a really strong data science component to it, especially because it's so data heavy and that data is so important. So my recommendation is to approach AI like a scientist more than an engineer. And what I mean by this is when you're implementing and testing AI, you're really running more experiments and seeing how they perform and then tweaking variables and running more experiments and creating more hypotheses, much like the scientific method. If you're somebody who thrives off of an immediate feedback loop with building something, like you like to say create mobile apps and immediately see the button that you made show up on the screen and be able to click on it, AI is not really going to do that for you. It takes too long and the results are usually just an accuracy number. So it's rewarding in other ways, but if you're somebody who needs that immediate feedback loop, AI might not be the best thing. So with that in mind, it is easier to go from AI to SWE than vice versa. And the reason for this is because you need to know how to code to do AI, and these coding skills are generally what's just required for the industry. So you will learn solid coding skills while doing AI, especially in Python. And then on the flip side of things, SWE, particularly app and web development, while it's not easy by any means, it's easier to self-teach than it is to self-teach AI. And that's because to really solidly understand AI, you need that mathematical foundation that's not really there for app and web development. And so what this looks like in the industry is that companies will more likely hire for SWE roles with people with AI experience than the converse of hiring for AI roles with people with SWE experience. So this was my experience. So I basically had entirely AI education, 3 AI internships, and when I applied for a SWE role after my internships, that was no problem at all. But I don't think that had I had no AI experience, I would have been able to be hired for an AI role. So that's something to keep in mind. So my recommended tip is that if you're really on the fence and you are just torn between whether you love AI more or you love software engineering, building apps, building websites more, then AI might be the safer bet just because it allows you the flexibility to switch in the future more so than software engineering, I would say. Okay, the seventh insight is that AI takes a long time. So in the micro and macro sense. So creating models is very complex and there's lots of bugs, as I mentioned, from these libraries. And these bugs can be hard to find because these libraries are very deep and there's lots of code. So they can be very hard to find. So that takes a while. Also, each individual training iteration can take many hours to many days. So the models that we've been training in class, they have been kind of reduced to a smaller size, but usually you'll be training much larger models. In order to get good results, these will take a very long time for each iteration. And you need to do many, many iterations in order to tune your hyperparameters. These are things like your model architecture, your dropout rate, learning rate, regularization, stuff like that. So all these parameters they all interact with each other, and you need to test out all these different combinations. And so that can take a long time, and it can be very consuming. So my recommended tip for this is to test your model on small batches to make sure it runs. So I wouldn't say code up your whole model and then press run for 100 epochs and then leave for the day, because your model is probably going to fail and you're going to waste a whole day. So test your model on small batches to make sure it works, and then automate the training process as best as you can. Automate through all those different combinations of hyperparameters so you don't need to be sitting at your computer the whole time. Okay, the 8th tip is that data preprocessing is crucial. So your algorithm is only as good as your data. Remember, the whole purpose of AI is to find patterns in your data, and data is messy. So if your data is messy, you're not going to get good results. So that's why it's necessary to have clean data. And luckily, there's lots of statistical methods that you can do to clean up your data, whether it's removing non-values or joining data sets together and rearranging the sources so that the format is provided in an interpretable way to the model. All these are really important to do. And pandas will be your best friend. Pandas is what we've been using in this class, so you've got an exposure to it. And this is what we do to explore our data. And just like we've been doing in our class, the #1 thing I recommend is to conduct a thorough statistical analysis of your data before you begin constructing your AI model. This will lead to a lot of insights about your data and will really help you construct your model after you've created this analysis. Okay. So 9th tip is that a lot of novel AI requires a PhD. So without a PhD, if you go into industry, most likely you'll be implementing existing AI frameworks that have been created by other people. If you really want to create cutting edge AI, that will most likely require a PhD in most cases. The one exception is with academic research. Say if you're an undergraduate and you want to join a professor's lab who's developing cutting edge research, then of course you'll be able to contribute to this cutting edge field without actually having a PhD. Now, if you're actually in academia pursuing a PhD, well, then you're doing a PhD. But that's just something to keep in mind. And so my recommended tip is to determine whether you like building or discovering AI. If you like discovering AI, then you'll probably want to spend longer and pursue a PhD. If you just like building AI, then it's possible to do a bachelor's or a master's degree and be able to have the skills required to build AI models. Okay. And finally, #10, AI unlocks a ton of opportunities. So AI is used across tech, finance, healthcare, government and military, consulting, and many, many more. You can do all kinds of fields with AI. AI also looks great on a resume. It's a really impressive skill. People know that it's rigorous, and people know that AI engineers are very well qualified. And right now happens to be a great time to join the AI industry. AI is still booming. There's still applications that are being discovered every day, and there's such a potent need for it in our world to make more rational and educated decisions using AI. So my tip is that you can do many things besides AI with an AI degree. So if you're somebody who's like, well, I'm really interested in AI, but I'm not sure if I want to be coding my whole career, which incidentally is me, you can do many things with an AI degree besides AI. So you're never limited in what you can do with an AI degree. All right, so those are 10 things I wish I knew about AI before pursuing AI. And I hope that those are going to be helpful for you guys when you're making your decisions about what to study more in depth in college.